Hello there. Thanks for coming along to this session here. I know it's the last one of the day, so I will try not to put you to sleep. I'm doing my best on this one. We're going to look at multi-site always on. And when I say always on, I do mean both parts of it, failover cluster instances and availability groups. We're going to look at some of the configurations and considerations you need to take into account when you look at building a multi-site environment for always on, be it between two of your on-premise data centers or Azure. Okay. So, quick thing about me. I'm John Martin. I'm a Premier Field Engineer for Microsoft. I've been working with SQL Server for over 8 years now. Worked in the dev, BI, and operations arena. Main focus is on high availability, disaster recovery, Microsoft Azure, and performance and scalability of systems as well for SQL Server. So let's have a look at what we're going to be covering. I'm going to look at what is always on, so we'll have a quick overview of what it is. Just out of curiosity, how many people here are familiar with the always on offering, your DBAs, and you're aware of it? Awesome. How many of you have got multi-site implementations already? Great. So I take it most of you are here just to see, is it done right, or is there anything you can pick up? So if you've got any questions, feel free to sort of raise your hand, and I'll do my best to answer them as we go through. We have got questions at the end as well. So we'll look at the Windows Server failover clustering options we have. There have been enhancements through the various versions. Obviously, Windows Server 2003 is end of life this year. SQL Server 2005 is end of life next year, so there's going to be a lot of transition from those clusters up to always-on availability groups and failover cluster instances as well. We'll look at both failover cluster instances and always-on availability groups, the configurations you have around getting the data between sites, be it storage replication, FCIs, some of the considerations around synchronous or asynchronous, multi-site HA, and disaster recovery. We'll look at the storage configurations, and then we'll look at some of the networking and client connectivity side of things as well. Okay. So we'll run through this. We'll say, what is always on? Always on is a marketing term, if you will. It's a brand for the high availability technologies that we have within SQL Server, introduced with 2012. Incorporates FCIs, failover cluster instances, and availability groups. Okay. What is your, just a quick question to show of hands on this one. What is the, who's mainly got failover cluster instances in their environment? Who's predominantly using availability groups? How many people have got a pretty 50-50 mix? Okay. So, sort of a bit of a third of everything there. So, we look at availability groups. It's a combination of database mirroring and failover clustering elements as well. Okay, so we've got the database level replica that we have with database mirroring, and we have failover clustering, effectively arbitrating the failover, who's active, which one's primary and secondaries, and what have you as well. The important thing to understand about availability groups, and from an operational perspective, it's very, very important, is database level protection. Even though it's a collection of databases, you can potentially be looking at having to do additional operations around synchronization of logins, jobs, linked servers, anything like that that you've got scripts or jobs or code that potentially needs it. Okay. You can offload read operations to active secondaries. There's some considerations around that as well. The primary element needing to understand there is that if you're not using a snapshot isolation model in your primary, when you enable it on a secondary, you can have the potential to increase fragmentation in your primary system as it sets the primary replica up for the versioning tags on the end of every row. So something to consider there. Multi-site and multi-sub capabilities came in effectively with SQL Server 2012. Prior to that, if you wanted a multi-site or multi-subnet implementation, you couldn't have a multi-subnet implementation with SQL Server 2008 R2 or before. The only way around that, to have multiple sites effectively, was to have a stretch VLAN. And some complications, and that got some complexities to it that in the networking tier that can have some impact on the performance. Then we look at always-on availability group, failover cluster instances, sorry. Again, leverages failover clustering. It's instance level protection. So the instance is active on any given server, one server at any given point in time. Whereas availability groups, you have active instances on every single node in the cluster that you've got it installed to, and the availability group is managed within SQL Server. Here we're looking at one instance that will be active on a node. If that node goes down or if you move it, it will become active on another node. We're looking at shared storage requirement for that one. If you want a multi-site environment, you need to look at storage level replication. Now, in this scenario, you're either looking at SAN level, block level replication, or software level replication. There's various vendors for both of those currently here, so useful to have a chat to about those. But essentially what you're looking at there is ensuring that anything that does the data synchronization maintains the log files and the data files in sync. Basically, they are synchronized. They don't end up ahead of one another, because obviously your databases can't come online, and in that situation, you have problems. An example being one customer I worked with at the tail end of last year were synchronizing all of their transaction log volumes and then separately synchronizing all of their database volumes between two SANs. Trying to bring their databases online was an interesting operation, and there was a very interesting discussion afterwards as to why it didn't work. So understanding how you do that storage replication can be very, very important. And again, we've got the multi-site and multi-subnet capabilities. Okay. The multi-subnet capability, as I said, came in with SQL Server 2012. Effectively, Windows clustering could do it before 2012. However, SQL Server could not. It couldn't handle the OR dependency on the IP addresses. Resolved in 2012. Again, there in 2014. So why use a multi-site configuration? This is an interesting one to say, and illustrated very well by a colleague of mine, in that open a box of matches, give everyone in the room a match, and then say, okay, you now all have the capability to take your entire business offline with a single site. All it takes is a small fire, which is a lot of things. It's one thing our customers that I've spoken to don't really appreciate, is that you've got the disaster, you've got your SAN going down, you've got a server going down, you've got disk failure. Not many people think about absolute site loss. One company I've worked with previously, we had multiple sites. The reason being is we were on the wire at an airport. So in the event of a catastrophic failure, it would probably involve an aircraft landing on the building. Wipes everything out. That's the situation where you need to consider the worst case scenario, and that's what multi-site can help you with. Okay, so it gives you increased resilience. Improved and simplified high availability disaster recovery. Now, if you've got SAN level replication in the mix, yes, you need to involve the SAN team, and to a lesser or greater extent, the networking team. If you're using AlwaysOn availability groups, then that comes back to being the realm of the DBA, effectively. You've got SQL servers in the various locations, and you want to synchronize the data between them. Your responsibility. Whereas previously, if you're looking at having very complex backup and restore strategies and topologies, you've got very large databases, for example, or you've got a lot of databases. You have a backup team that controls a backup software product that then uses an agent to gather all of those in. In the event of a disaster, large scale restore, then that team becomes a bottleneck. Again, you have to look at what your options are around that. By distributing the work in the event of a disaster, you can improve the performance and reduce your recovery time objectives and reduce your recovery point objectives as well. Always things to think about. The flexibility and scalability. The clusters have got bigger and bigger. We now have 16 nodes in a Windows failover cluster, up to 50 instances as well, if you're looking at running an FCO using things like SMB backend storage. So there's a lot of scalability there. You can build more advanced, more distributed environments. So for example, you can have 2 sites, 3 sites, 4 sites, depending on how you want to set it up. There are some considerations about the placement of nodes and the way you have them voting. We'll cover that as we go through. And higher service availability with a lower recovery point objective and recovery time objective. By putting the configuration and the power back in the hands of the DBA, you can effectively leverage the recovery point objective by using your point-in-time restore strategies, because the databases are running in full recovery potentially for AlwaysOn. May not be the case if you're running failover clustering with SAN level replication, but for AlwaysOn, yeah, full recovery, transaction log backups, then you're looking at being able to do point-in-time restores. And again, you can take that down to the database level granularity. Makes life a lot easier, so you can build a generic environment, and then host different services and have different tiers of disaster recovery and HA capabilities within those tiers. Any questions so far? Okay. So what does it look like? Here we'll look at single site HA with disaster recovery using an availability group. So in this scenario, we've got 2 nodes on our primary site, site A. We're running synchronous replication between the 2 with automatic failover. So we're simulating the classic 2-node cluster here. Asynchronously, we're sending data over to a replica on a second site. That's our DR. The reason I say it's a DR and not a HA option, excuse me, is because we're using async, and there's the potential for data loss, and that's where your recovery point objective comes into it. Now, with async, it's important to understand the operations you're doing in your primary database, because that way you can end up with a lag for log records being sent potentially. Additionally, the redo thread and what have you will have an impact on that and bringing it online. Now, when you do look to define your high availability and disaster recovery, it's important to actually give them firm definitions. High availability is automatic, disaster recovery is a manual intervention. You don't just want the system to go to DR overnight without you saying so or without you knowing, because typically it's a more complex operation. There's the application tiers to take into consideration, some of the supporting operation tiers. So high availability should be your automatic element. Multi-site HA. Again, this is something we can look at with availability groups. Now, in this scenario, you'll see that we have a site C. We've got a third site come into the mix for the file share witness. Now, typically, when it comes to the witness and the quorum for the cluster, and we'll have a look at that shortly, what you have to consider there is you want to put that share close to your unit of high availability. Now, we go back to the previous slide. Our unit of high availability is on site A, so we put the file share witness there. Here, we've got multi-site HA. So where to put the witness? Put it on site C, effectively, so both sites can see it. Now, an important thing to consider here where you're using a third site is how you do your traffic routing. So, for example, if you've got a site-to-site link between site A and site B, and then you have a site-to-site link between A and C and B and C, can you route through C to get to B? If not, and you lose the link between site A and site B, whoever grabs the witness first forms quorum. Okay? Again, with a multi-site environment where you're dealing with HA predominantly, what you're looking at here is also understanding where your clients are. In your traditional one that we looked at a moment ago, where you've got a primary site, which is typically where your client connectivity is going to be. So that's where you want quorum to form. That's where you want the service to be available. In this scenario, where are your clients? How do they connect? Again, something to consider here. We also have DR on the primary, or on site A. We've designed that's going to have a DR replica. We can run synchronous. If you've got the performance overhead there, you can take it. Otherwise, run it in async. But effectively, you're looking at 2 nodes that will be running with an automatic failover, 1 that will be running as a manual failover. Okay. You'll notice here as well that we're doing site-to-site synchronous data replication. Now, the important thing to understand there is going to be your data latency. How long is it going to take to get the records over there and hardened in the transaction log and the acknowledgement back to the primary? Because that will have a direct impact on the performance of your application tier. Okay. Finally, we'll have a look at failover cluster instance multi-site. We've got a similar scenario here. You've got an option of single-site HA or multi-site HA with this, depending on the complexity and typically how expensive your storage platform is, and how it will coordinate bringing the drives on the remote site online. Okay? Some systems require a manual intervention where you bring those LUNs back online, and then when you fail it over and manually, bring it back online. However, some of the more intelligent equipment out there, you effectively abstract that and the storage appears as a single set of storage, despite it being distributed over 2 sites. The SAN replication, as we said, looks to be done at the block level in this scenario, and effectively you want to bring all of the volumes involved into a consistency set. So all of the volumes that are handling your database files, all the volumes that are handling your transaction log files, all need to form a consistency set. So when a write happens to one volume, it happens for all of them, so they're at a consistent level. That means when you bring the databases online, everything's consistent. It should come online fine. Okay. If they get out of sync, that's a problem. You can look to use asynchronous SAN level replication. Again, it comes down to the complexity of the software that you're using at the SAN level, as to whether or not it honors write ordering and so on and so forth. Okay. Effectively, the most important thing to understand is all of those volumes need to be consistent. You'll notice that it doesn't say DR up there. Can anybody hazard a guess why? No one? Yes, please. Oh, sorry, I can't hear you. The site A is near to site B. Not necessarily. The reason I say there's no DR, well, there can be, so long as you're doing backups. If you get a database level corruption, your SAN will replicate it, which means your second site is null and void. Okay? That's the important thing to understand with storage level replication. If you have a problem on site A, it will replicate that problem to site B. Therefore, you've got the same problem in two places. Not great. I have seen issues where transaction logs become corrupt, and that's been synchronized between SANs. That was not a pleasant one to recover from. So if you're planning on doing multi-site failover cluster instances, it is very important that you are looking at effective backup strategy to support the high availability that you are looking to put in place there. You need to have something to fall back to. Availability groups, to a lesser or greater extent, can mitigate some of those elements when you look at the automatic page recovery that it can do. It can restore some elements of it. So even if there's a corruption in the primary, depending on what it is, it can potentially repair it. Failover cluster instances with that storage, where you've effectively got a single instance of your data, even though it's in two places. Very important to understand that. So, Windows failover clustering. This is what we build both solutions on top of. Okay? FCIs and availability groups both rely on Windows failover clustering. Now, another question for the crowd. Can I have a show of hands of who's still predominantly using Windows Server 2008 or 2008 R2 for their clustering environments? Okay. Windows Server 2012. And finally, Windows Server 2012 R2. Okay. The reason for that difference between 12 and 12 R2 will become apparent soon. But one of the important things to understand here is that we're looking at a single AD domain when we talk about Windows failover clustering. Okay? In order to build the cluster, back in the 2003 days, it was a lot more complex with the hardware compatibility list and so on and so forth. In 2008, we removed that and introduced the cluster validation wizard. But one of the main things to consider, if you want to build a cluster, single AD domain, because the reason we sort of emphasize that point is I still see a lot of customers where they've got multiple domains for their site, so they've got one forest with a domain for site A and a domain for site B. Doesn't work. You need the single domain. And passing the cluster validation checks. If you want a supported configuration from Microsoft, you need to pass those checks. Okay? Now this is the big one. If you can, deploy Windows Server 2012 R2 for availability groups and failover cluster instances. The main reason for this is dynamic quorum and dynamic witness. With Windows Server 2012, we introduced what is known as dynamic quorum. Now, this is a mechanism whereby the voting rights for the nodes within the cluster are dynamic. So in the event of a node failing, the votes of the nodes will be adjusted. Okay? So as long as you configure the system appropriately, you can fail back and have a greater number of nodes in your cluster fail and still have a functioning solution. It's one of the things that Windows Server 2008 and 2008 R2, the number of nodes in the larger cluster environments. So for example, your Windows 16 node cluster, you're looking at half the number of nodes or half the number of nodes minus one being your maximum failure limit before the cluster will lose quorum and go offline. So with Windows Server 2012, that was remediated. Windows Server 2012 R2 adds the dynamic witness capability. Okay. Now, effectively, this moves the voting rights over to the witness. So if the witness is online, that's what will have or give up the vote as the various number of nodes in the cluster fail. So if you've got 5 nodes, typically you wouldn't have traditionally put a witness into it. In Windows Server 2012 R2, we recommend you always deploy a witness. My personal preference, file share witnesses, because they make it more versatile, especially in a multi-site environment, where if you were to use a disk-based witness, you've got a lot more complexity when you look at the asymmetric storage configuration. Okay, so by using the file share witness, it gives you that versatility in the configurations that you can use. Just a standard SMB share for the cluster and you'll be fine. Okay. Again, Windows Server 2012 and 2012 R2 have native support for asymmetric storage configurations, and an asymmetric storage configuration is where you've effectively got your storage over 2 sites. Okay. If you want that capability with Windows Server 2008 R2, then you've got to apply a specific hotfix and KB to get that done. Okay. In a multi-site configuration, as we said, witness placement is very, very important. Place it in the same location as your unit of high availability, because that's where you want quorum to be formed. Effectively, that's the portion that needs to have the most votes. Okay. As we looked at a minute ago, multi-site HA or DR. If multi-site HA, then you need to look at the routing of the traffic. Can you route through the third site? So your cluster nodes can still see each other, albeit with potentially a greater latency, but if in the event that they can't see each other, that's when it gets a bit more complex. And like I say, the first one to effectively lock the witness wins the quorum, and that may not, it may give you unpredictable results in your service availability. One of the key things you're looking for in a highly available solution is predictability. Okay, so in the event that you have got a scenario where you've got to route through the third site, and you know that link's going to be down for a period of time, you can change the heartbeat settings and so on and so forth to give yourself handling the greater latency or potentially more heartbeats being dropped out. Okay. Any questions about any of that so far? Okay. Understanding the nature of the multi-site topology again. Network latencies and bandwidths. How much data are you going to be transmitting? How much transaction log do you generate? Do you have big tables? Do you do re-indexing every night? That's going to generate a lot of transaction log records potentially, which will need to be synchronized. If you've got synchronous replicas between sites, that can slow these operations down. So do you have to look at some of the operational side of things to say, okay, we've got a window where there's no data coming into the system. It is acceptable for us to switch to an asynchronous configuration to perform the re-indexing or what have you, and then switch it back to synchronous, and they will come back to a synchronized state before we start receiving data into the system again. So understand that. Traffic routing we discussed already in a multi-site configuration. And the supporting infrastructure. You've got 2 sites. Do you have the supporting infrastructure for Active Directory, DNS, file servers? Do you have client connectivity? So for example, you've got 2 sites. Do you have your internet connection only coming in through your primary site, which you then typically route to the secondary? Sounds silly, I know, but I have seen that. One customer I've spoken with, yep, everything comes in through here and we just fail it over to there. And it's like, but what if you lose that link? You can't get your internet connectivity traffic down to there. Again, thinking about that and then understanding what network infrastructure you have to have in place for that. The big one as well around that is DNS. And you think about DNS replication. If you're using a multi-site AD configuration, how long is it going to take for things to replicate through? So you make a change in one DNS site, how long is that data going to take to replicate to the other? Can be very quick, can take 15 minutes. So understand that. So now we'll have a quick look at cluster quorum configurations. We'll just try to figure out exactly how to get my VM up and running onto the screens. Sorry. Just need to get that display. That's the wrong VM, sorry. No. That's the one I want. Do that. No, that's not the... That's better. Sorry about that. Right, okay. So, what we've got here is I've got a 3-node cluster with availability groups running on it. Okay, 3 availability groups. So if we look at our nodes, I've got 1, 2, and 3. You'll see we've got an assigned vote. We've got a current vote. This is just going to illustrate how the voting is managed automatically within the environment. So if I come back to here, ignore the errors at the top. That's because I have been breaking it. We've got file share witness. Just to prove that we've got a multi-site environment, I've got 2 IP addresses here. Okay. Effectively, we've got one subnet 1 and one subnet 2. Because the cluster group in this instance is on subnet 1, that's why we have an active IP address and one is offline. Now, for those of you that don't have a multi-site environment and are used to single-site clustering, the reason we've got here is we've got an OR dependency, so one IP address or the other will be online, given depending on which subnet it's in, basically. As you do the failover, one go offline, the other one come online. You'll notice also we have our file share witness. Now, you notice that we've got assigned votes and current votes are all 1. So if I take the witness offline, okay, we still have current votes all the way through because we've got an odd number of nodes. It doesn't matter that the witness has gone in this instance. Now, if I just come out to here and we will shut down, hit save. This should take our cluster node offline. Normally it's a lot easier because I do this with a 4-node cluster, but this laptop hasn't got the memory. So we've taken one offline, but because we've got the witness down as well, we'd have 2 servers running, which means that potentially, I mean, under the old 2008 system, we still have 2 votes, which means we've got an even number of votes, which means that's not great. You'll notice here that the current vote has also been taken away from this system. Okay, so when you scale that up to your larger clusters, again, this is dynamic witness this is dynamic quorum in effect. So it's taking the vote away. If I bring that machine back online again, start, give it a moment. It says, okay. It should come back online, he says. Give it a moment. But I'll go and bring the witness back online whilst we're here as well. Nodes. So now we've brought the witness back online as well. The witness has got a vote. We've added the vote back here to the current one as well, so we've got an odd number of votes again. So again, we've got dynamic witness, dynamic quorum. The upshot of this is effectively that it means that you can now go back to a last man standing position with your cluster in the event of a failure. If you have a progressive failure, node, 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 or node witness, node, 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 so long as it doesn't all vanish at the same time, then again, if you've got the system configured appropriately, everything can go back to running on a single server if it's scaled appropriately and that's what you want it to do. Just bear that in mind. Okay, yep, we're back online. Again, it's come back online, it's got its vote back. Okay. So, any questions about any of that? Okay, just a quick illustration of the clustering and quorum there. Like I say, the big thing as well to remember is the placement and the number of nodes that you have in each environment or outside. So if we look at if we think back to the original slide where we said we had HA with DR, so we've got our primary site. We had 2 nodes on one site and 1 node on another. Okay. Where we've got our unit of high availability, we want to have at least 50% of the nodes plus the witness. Okay, so you want the majority of the cluster in that primary site. So if you think about spreading it out through number of sites, understand how that's going to have an impact on the number of nodes you have to place there. Because if you've got the primary site and you lose the connectivity, if you lose 50% or less of the cluster nodes, the primary site will remain online. If you lose more than 50% of the cluster, so it's outside of it, so for example, you have 2 nodes there, and then you've got 4 other sites with nodes on, so you've got 4 outside of it. If you lose connectivity to the outside world, then your cluster will go offline because you don't have the majority of the nodes available to you. Okay. In that situation, you'd probably want to look at going in and manually taking votes away from some of the nodes that are outside of that environment. Okay, so you can manually go in and configure that. So we extend again. Yes. So now we'll think about storage configurations. Availability groups. Now, when I use the term local storage, it still can be SAN level storage, but it's effectively storage that is dedicated to that particular server. Okay. SQL Server will handle the transfer of the data between the replicas. It will send the transaction log traffic over to the replicas. It will be hardening the logs there to get the acknowledgements back. The commit will go back. That's in the synchronous. Asynchronous. As soon as it's sort of committed locally, it says, yeah, I'll deal with the remote stuff. Not a problem. I'll deal with it. Honest. Multi-site failover cluster instances, as we discussed, require SAN level replication. Storage platform needs to be block level. It can be expensive. It can be complex to put in place. It's something to really sort of think long and hard about how you're going to do it. One of the configurations I've used previously is a combination of failover cluster instances and availability groups to do the data replication between failover cluster nodes. Okay, so I had a 2-node cluster on site A and a 2-node cluster on site B, an availability group between the two just to synchronize the data. So I didn't have to go down to using SAN level replication. The reason behind that, the SAN that we had didn't have the feature set to automate it. It was all manual in order to bring the volumes online. And also the amount of data that was changing at any given point in time, because it's block level replication, the link would become saturated with the SAN traffic. Whereas by using transaction log traffic that the availability group does, we could get savings and efficiencies in that data synchronization between the two sites. Okay. So just think about which way you can do it. They do interoperate very well together. When you are using the two together, just remember that the failover cluster instances are the bit that will handle the automatic failover. The availability groups will have to be a manual failover. So, storage configuration for the FCI. 2 SANs, asymmetric, present different volumes to the cluster. Now, in certain situations, you'll have 2 complete sets of disks that are presented to the cluster nodes. In that situation, half of them for, say, site B will be offline and half of them will be online. And then when they go across the other site, if you've got the appropriate software and then the SAN's capable of it, then those drives will come online, will be presented, the other ones will go offline, you'll be able to transact. Okay. There are certain SANs out there as well where they completely abstract that, and both sites will appear as one set of volumes and the SAN will handle all of that. So a distributed SAN in effect. So just understand which one you're likely to be dealing with in that environment. The asymmetric storage configuration, as I said, under Windows Server 2008 and 2008 R2 requires a specific hotfix. It's up there, 976097. All of this type of stuff is listed in a TechNet article about the prerequisites for availability groups under some of the, and it's basically got a tick list for 2008 operating system, 2008 R2, and 2012. When you look at the 2012 column, it's basically, a lot of it doesn't apply because it's built into the OS. Okay, that's another reason for looking at 2012 and above as an operating system. Okay. Half the storage online, offline. Synchronization must ensure the volumes are consistent. That's the really important thing there. And as I said, bringing the secondary site online can be a more complex operation. SAN level replication is done at the block level, which means you can end up, depending on how the data is distributed among the SAN, even if you're just going and touching individual pages, if they're in the wrong blocks on the SAN, it means it's going to synchronize the whole block, which means you can end up with a lot of traffic being sent across the link. And that's why, as I said previously, I had 2 failover cluster instances with AGs handling the data replication. Snapshot, synchronous, asynchronous, there's various different options that are available again. If you're using snapshot, you're looking at a higher data latency between the 2 sites. So you take the snapshot, it synchronizes the snapshot. Okay, how long is that going to take? What is your potential data loss scenario in that situation? Asynchronous, again, something to understand. Synchronous. One thing I've been working with a customer quite recently on is where they've got 3 cluster they've got 3 2-node clusters. Okay, they're using distributed transactions with databases on each cluster. They're using SAN replication for those failover cluster instances from site 1 to site 2. Because they need to ensure logical consistency for all of those distributed transaction databases, they've got to put all of the volumes for all of the cluster instances into the same consistency set and are performing synchronous data replication at the SAN level. That had a performance impact, and they needed to basically increase the size of the pipe between their 2 sites. So again, think about the larger infrastructure. It's all well and good just synchronizing those ones and those ones and those ones in 3 different consistency sets, but whilst the databases would be consistent, the system as a whole, logical consistency, was at risk. Okay? So again, that's something to think about. The reason we didn't use availability groups don't support distributed transactions at this point in time. When that will change, I don't know. And as we said earlier, corruption will be replicated to the DR site. It does happen. I have seen it happen. One place I worked many years ago, large SAN, 3-site scenario. Wrong drivers installed on 2 of the servers, corrupting data as they wrote it down to the SAN. The SAN then replicated that around all 3 sites. 5 terabytes of total data loss. Yes? Sorry. Could I ask you to just use the mics, the microphone just here in front of the table? Sorry, my hearing's not great.
My voice is... Yes. The other scenario is the storage admin's human mistakes. It happened.
Yeah.
It just, when taking clones, just changes the source and destination, and source goes off.
Yeah, you do need to be careful about the operations that you're performing at the storage level, cloning, transferring data, what have you. Like I say, it was something completely outside the realm of SQL Server when it was set up. Wrong drivers for the HBAs, corrupting data as it was. So basically writing junk down to the SAN. It wasn't a good situation to be in. Just a little diagram there. We're looking at the replication at the SAN level away from SQL Server. Now, availability groups, as we said, make sure use of effectively local storage or locally presented storage. SQL Server handles the data synchronization. The data synchronization is not true data synchronization. It doesn't synchronize the data files. It synchronizes the transaction log blocks, which are then replayed into the databases. Okay. What does that look like? Well, here we go. We have a number of nodes. We've got the availability group, and we've got a collections of databases there. We've got primary replica and the secondary replicas. The big advantage here, you'll notice over database mirroring, which is the older technologies, whereas that you'd have a single database and it would be a single mirror, a single replica, or single mirror. Here you're looking at multiple databases in the same availability group and multiple replicas. Makes life a lot easier. Okay, how are we doing for time? So, optimizing transaction log storage. This is very, very important. Something I still see an awful lot of customers doing is putting 20, 30, 40 transaction logs into the same volume. Try to avoid that with availability group configurations. The throughput of the availability group is going to be determined by your transactional performance effectively, in addition to the latencies of sending the data around. Okay? Making use of storage that has a lower latency as possible. Have you got a big cache that's going to take it and is battery backed and will flush it down to the disk later so you can effectively mask your underlying disk performance? Things like that. Understand what you've got. So, storage configuration example, here we go. We've got 2 servers, transaction log on both. So we hit our update or insert or what have you. We're going into our primary replica here. Again, this is another difference between mirroring and availability groups. We send the transaction log records at the same time now, whereas before it would harden them remotely, then do it locally. You'll notice we get the acknowledgement back. Now, if in a synchronous environment, we're not going to issue back the commit to the application yet, because we need to wait for the acknowledgement coming back. It's been hardened in the transaction log. That information is then acknowledged back to the primary replica, which then goes back to the application and says, yep, I'm done. Okay? When you're working out whether or not you're going to go synchronous or asynchronous across these links, you need to understand effectively what your latency overhead's going to be. Now, certain applications such as System Center and SharePoint can be very, very sensitive to latency. Okay? So just bear that in mind if you're looking to use in conjunction with, like I say, System Center, where you're looking at 1-2 millisecond latencies is what it's expecting. Okay? You start introducing multi-site environments where you go synchronous, you're going to end up with performance issues. So just understand that. So if you've got the chance, do a lot of application testing. If you can capture a workload, trace extended events, that sort of thing, and then replay that workload into a configuration that you're looking to test, understand what the performance impact and overhead is going to be of putting that configuration in place. Any questions about storage side of things before we move on to networking and connectivity? Okay. Networking and connectivity. Again, it's all about network latency with availability groups typically, and depending on the configuration and network you've got for synchronizing your SAN traffic, that's something to think about as well. If you have got an unreliable link or you've got a great distance, so for example, you've got a data center in Copenhagen, you've got a data center in Los Angeles, you're going to need to look at potentially tuning the heartbeat there, increasing the amount of time it takes for the data, for the heartbeat to travel around, and also potentially the number of heartbeats you can lose if you've got an unreliable link. In a multi-subnet environment, you're going to need 2 IP addresses or more if you've got more subnets, and they'll have the OR dependency, so one is active at any given point in time. Okay. DNS configuration as well needs to be looked at and optimized. Now, there's a combination here of understanding what cluster configurations you need to put in place, but also your client connectivity. Okay. The reason I say this is, if you're using multiple IP addresses, the default behavior of the clustering system is to register both IP addresses in DNS. Okay. The default behavior is effectively to round robin between those two. If your applications are going to be connecting through hostname, ideally you want to be looking at using the SQL native client 11 and above, or JDBC 4.0 and above if you're using Java apps. The reason for this is because you get the multi-subnet failover parameter. Now this changes the behavior about how the application will effectively go and obtain the IP addresses for the host name that it's going to be connecting to. Okay. With multi-subnet failover parameter on, effectively it goes in, grabs all of the IP addresses, tries to bind to them in parallel, and then disposes of the ones it can't connect to. Put very simply. Okay. If you're not using the latest client drivers that have this capability, if you're using 2 IP addresses, you could potentially look at reverting to the older mirroring type connection strings if you've got that versatility to go into the connection string itself and manage. So if you've got a web.config or something like that where you've got control of the full connection string. Alternatives, if that's not feasible. If you've got an application, looking at System Center again, where you provide the information in through a form or a configuration panel, you don't have the full control of the configuration connection string, so you can't add the multi-subnet failover parameter. You can modify the behavior of clustering using the register all providers IP setting, okay? As I said, by default, it will register all IP addresses. You can turn that off, so it will only register the active IP address, okay? If you're going to do that, you need to seriously consider looking at the TTL value, the time to live for those DNS records. You want that really low because it will affect your failover time. Okay? Default is, I believe, 20 minutes for a registration in DNS. So in the event if it fails, it changes the IP address, you're potentially looking at 20 minutes in order for it to for the client effectively to flush its cache, come back and say, I need to replace this stale record. What have I got? Okay? Values I use, typically 30 seconds. Depending on how quickly the system's going to fail over, you want to add as little time as possible into the mix where it's got to go and reestablish the connections. Okay? And as mentioned earlier, DNS replication between the servers. So we'll have a quick look at DNS configurations. So if I duplicate again, and then, no, thank you. So, if, no, that's not the one I selected. DCO1, thank you. So, give me a second, we'll just come into here. So, I'm on my domain controller. I'll have a quick look in DNS. Now, you know we had 3 availability groups earlier. Look at our forward lookup zones. So, I'm very, very unimaginative when it comes to my availability group listener names. So, AG, availability group, L, listener, 1, for availability group 1. So I've got 2 records there. I have 2 records there for availability group listener 2 and 3. As you can see, I've got 1 IP address for each subnet registered in DNS. That's the default behavior. So, we want to change that. So, let me just go back into this one here. Get the password right, which is always a winner. How do we change it? PowerShell is our friend. So, there's my cluster name. That's the cluster group we're going to change, AGL01, or AG01, and we're looking for the network name. So, if we look at the roles, AG01, there's our network name, and those are our 2 IP addresses. So at the moment, subnet 1 is active. Right. So what we're going to do is come in here. We're going to set it to false. I'm going to set the TTL value to 30 seconds. Because what you do is you can set that in clustering. So when it registers the IP address, it goes in and registers it with the TTL value you assign here. So if you go into DNS and you right-click, change it, next time it recreates that host record, it will revert. Okay. This is just a generic script, so if I'm turning it back on or off again, it does what I need to do. So what we'll do is this code here effectively grabs the cluster details, looks for the appropriate network name, and then sets the value to false. You'll notice that it needs to go offline and then online. But additionally, we also need to set the TTL as a separate operation. So we'll do that. I'll do it manually, just so we can see this. So I know you shouldn't do this through clustering. Bring that back online. Okay. There we go. We're online. online as well. Come down, DC01. Now we should, if it's all worked properly, we now have our single IP address in DNS. Okay? And just to prove I'm not lying, come on, I thought I'd turn that one on. View advanced, properties. There's our TTL that we set through the clustering tier. Okay? So if you've got legacy applications, things that can't use the latest connection drivers, there is a way to make use of the new technology and still present the connectivity layer that you need in order to make use of it. Okay? So very, very useful there. And as you can see, it's done on an availability group by availability group basis. It's not done on a cluster-wide setting. Okay? So you can mix and match the two. At the availability group level, obviously you can't do it within the same availability group and the records that you have there. Any questions about that? Okay. Nope. Okay. Right. Sorry, I can't. Can I ask you to use... Oh, yeah. Sorry. Like I say, my hearing's not great.
I have a question about if you do a multi-subnet environment and you want to use DHCP for the listener. That's done in the Failover manager.
Yeah.
But you can't see the listener from the SQL. Is that going to be available soon?
If you want to use DHCP for the listener?
Yeah, in a multi-subnet environment.
Yep.
You can't do that out of SQL. You have to do that in the Failover manager.
Yeah, I mean, typically, DHCP is not a configuration I would recommend for the listener.
But it's dependent on some policies in the company.
Yeah, it does depend on the policies. Yeah. Where possible, I would always look to go for the static IP addresses if you can.
Yeah, me too, but yeah, I'm forced to it. So what I'm saying is it's hard to manage because you can't see it in SQL.
Yeah.
Wouldn't that be possible some way to...
I'd have to go and do more investigation on that one for you.
Because we're doing it and it works fine, so...
Okay.
As a network name in the Failover.
Right. So you're having trouble with it at the moment, trying to... I have
no trouble with it, but it's a problem you can't see it in the management studio. So you have other managing it and say, oh, there's no listener. Yeah, there is a listener, but it's somewhere else you have to look for it.
It's an interesting one.
Yeah.
Sorry. Yeah, I mean, if we can take that one offline afterwards, I can understand exactly what you're doing. And I can show it to you again. Yep, we'll do that afterwards. That'd be great. Cheers. Sorry about that. Right. Availability groups, network connectivity. Another one to think about as well in multi-site environments will be where you're looking at going between sites, you're looking at going through firewalls, the ports that you're going to be synchronizing your transaction log traffic on. You need to understand what that is. Obviously, you can define that on the endpoints when you create them. Make sure that traffic can get through. Whether or not you're going to use a dedicated IP address as well, understand the complexities around that. Are you going to use a dedicated network? Or are you going to use an IP address that's sat on an existing network? Okay, how are you going to handle those? What are you going to do with regards to adding that in as a resource so that it can be detected in the event of that network failing? Okay. Again, that's something that some people have looked at. Adding it in as adding the IP address resource in, allowing bind to, but then effectively setting up the dependency so in the event that that network fails, the group will fail over as well. Something to think about. It's not a normal configuration, and it takes a bit more thought to look around. Read-only routing as well, understand that. So if you've got clients on your primary site that will effectively be routing connectivity over to the secondary site, how's the application going to impact that? Are you running synchronous, asynchronous, all that sort of stuff? Read-only routing as well, the important thing to understand is if you want it to work really well, static ports for your SQL Server instances, because you define the read-only routing URL is effectively a TCP string with a port number. If you're using dynamic ports, that will change. So you potentially have to look at going in and refreshing those particular URLs when you do a restart. Not great, but static ports, a lot of the customers I speak to use non-standard static ports anyway for a lot of their SQL Server environments as part of their security hardening. Again, something to think about. Questions? Anybody? Pretty much run to time, I think, if the clock on my laptop's right. Has anyone got any questions at all? Obviously, we'll have a quick chat about what you're doing with DHCP. But if not, then thank you very much. Please explore all the stuff that PASS has to offer. I don't know if anyone here is going to be at SQL Bits this week in London. It's a great conference. If you can't make it this year, try next year. Otherwise, PASS Summit is the last week of October this year, so hopefully see some people there. So in that case then, thank you very much for staying to the end of the day. All the best.